Okay, and we're back now for video lesson number 14, derived units and density. So what is a derived unit? It is a unit that is a combination of two or more units. So for example, if we take a look at velocity, velocity is distance over time. So meter per second, kilometer per hour. Okay, are examples of derived units for velocity. Volume is length times width times height. So if we had centimeters, you'd add centimeters times centimeters times centimeters, which gives you centimeters cubed. Any cubic unit, any cubed unit, centimeters cubed, inches cubed, meters cubed, any cubed unit is a volume unit. Now, how do we get milliliters or liters from that? Well, a centimeter cubed is equal to 1 milliliter. So a milliliter indirectly is a derived unit. Density is mass over volume, so gram per milliliter, gram over centimeter cube, because volume is a cube unit. These are all combination of units, and so therefore they are derived units. So we're going to focus the rest of this video on density. Density, we know, is mass over volume, and so we're going to take a look at some density problems. Now, I want you to start using a problem-solving format. I want you to start listing givens. I want you to list the unknown. The plan is either how you're going to do conversions or an equation. So let's list what's given in the problem. If a sample of aluminum has a mass of 13.5 grams, so we have this quantity here, 13.5 grams. We want to list that in our given. And use the abbreviation that you have. So M is equal to 13.5 grams. Okay, M for mass. And volume is equal to 5.0 centimeters cubed. And how do I know? Well, it says volume of 5.0 centimeters cubed. And so what we want to find is the density. So our plan, very simply, is the equation. Density is equal to mass over the volume. The solution, we're just putting in those numbers. So we have 13.5 grams over 5.0 centimeters cubed. Now when you have an equation set up like a fraction here, it's 13.5 divided by 5.0, sig figs. 3 and 13.5, 5.0 is 2, so you want two significant figures in your answer, which would be equal to 2.7 grams over centimeters cubed. Unit must follow the number. Okay, this is a calculated measurement. Next, what is the volume of a sample that has a mass of 20 grams and a density of 4.0 grams? So our given is mass, and we have 2.0, or I'm sorry, 20. Let me kind of get rid of this. 20 with a decimal point grams. That decimal point is significant because it tells us the 0 is significant, so you have two sig figs there. The density is equal to 4.0 grams per milliliter. Alright, our unknown, we're asked to find the volume. So volume is the unknown. Now our plan is the equation. So we have density is equal to mass over volume, and you can simply put in the numbers, 20.4 grams, the density, or we can solve for the volume. And the best thing to do here is you have to multiply both sides by volume. So volume divides out of this side. So then we have volume times the density is equal to the mass. We want to get rid of the density on this side, so we're going to divide both sides by density. Density divides out here, so volume is equal to mass over the density. and plug in your numbers. So you have 20 grams over 4.0 grams over milliliter. Grams is going to divide out. And to two significant figures, we will have 5.0 milliliters as our volume. Okay, last, we have gold having a density of 19.32 grams per centimeter cubed. And if a chunk of gold occupies a volume of 135 centimeters cubed, then what is the mass? Now, why did I say volume? It doesn't say it in the problem, but I recognize that 135, or that centimeters cubed, is a volume unit. So I made that connection right away, and that's what I need you to do, is to be making connections. So the given, we have density is equal to 19.32 grams over centimeter cubed. The volume is equal to 135 centimeters cubed. The unknown is equal to the mass. And so our plan is the equation. And again, density is equal to mass over the volume. We want mass, so if we multiply both sides by volume, volume divides out of this side, and we would get mass is equal to the density times the volume. Plugging in our numbers, we have 19.32 grams over centimeters cubed. This is a 9 here. The loop didn't close up there. Multiply that by 135 centimeters cubed. Centimeters cubed divides out, and when we multiply those together, round to three significant figures. 135 is 3, 19.32 is 4. We get 2,608 grams, but we want 3 sig figs, so 3 comes out to the 0. There is an 8 after the 0, so the 0 is going to round up to 1, and then we're going to put in a 0 for a placeholder, so our answer is 2,610 grams. Think about it. 2,608 can't run down to 260. It can only round up to 2,610. Alright, that is video lesson 14. Until video lesson 15, this is Mrs. Sweethy. Goodbye for now.